All right, so 19D volumes of evolution. A culture is started with an initial population of 100 bacteria. The rate at which the number of bacteria changes over a month of the period can be modeled by the function blah, where R is measured by bacteria per day. Find the population of bacteria 20 days after the culture was started. So you need to take the derivative, the integral, of e of 2.273t dt. And that's because this is the rate per day. So you take the integral, and you're going to get e to the 0.273t over 0.27273 plus c equals f of x. And then you want to find the initial population bacteria, so you plug in 0. So e 0.273 times 0 over 0.273 plus c equals 100. E to the 0 is 1, so that's 1 over 0.273 plus c equals 100. I know you can't see this, but I'm going to do 100 minus 1 divided by 0.273, which is 96.336, so 96.34. So your equation is e to the 0.273t over 0.273 plus 96.34 equals f of x. And then now they want you to plug in 20 for 20 days after the culture was started. I know you can't see this, but I'll take a screenshot. E to the 0.273 times 20 over 0.273 plus 96.34. Some inception here. Calculator didn't copy. And it goes right there. So there's the warm up. So I know I have a video. We're not gonna watch this video, but I have a different video. I'm gonna link it into the description. Is it down there? I point there, or maybe it's up here. I'm not sure how it works, but there's gonna be a link to the description. If you can like pause what we're doing and then go to this video and come back, it's gonna look something like this. Oh, it's not working, so it's this video, but we'll and you can watch it, but I really want you to focus on when it rotates. Okay, so essentially you're taking this function and it's rotating around, creating a 3D solid. So here's the original graph. You rotate it around and you get this 3D solid. You have infinitely thin disks, which are circles. If you find the area of the circles and you add them all across, you get the ball. So the equation is pi, the area of a circle is pi r squared. And then this bounds find you the height. So it's pi times a from a to b of f of x squared dx. And usually the squared makes it a really nice answer. Biggest mistake students do is they forget the pi. So just be careful. There's another one called a washer. So that's sometimes when you have a function and you rotate it and it has a hole in here. So you're going to do this function here. It looks like a washer if you're ever into construction. And then that's when you do the top function minus the bottom function. Each of them squared from pi from a to b. So pi, I always use this thing called big R squared minus little r dx from a to b, where r is the top function and this is the bottom. And this is because this is the little radius and this is the big radius. So that's how I got it. So use integration to find the volume of the solid generated when the line y equals x from 1 to pi times 1 to 4. And then x squared dx. So integrate that. You get x cubed over 3 from 1 to 4 times pi. 4 cubed is 64 over 3 minus 1 over 3, which is 63 over 3 pi, which equals 21 pi. Very nice. Find the volume of a solid form. The graph of function x squared is revolved through 2 pi around the axis. 2 pi just means full revolution. This is x squared from 0 to 5. And I need to draw an arrow of my rotation. So integral pi from 0 to 5 x squared dx. So it's x to the fourth 0, 5 pi. X to the 5 over 5 from 0 to 5 times pi. 5 to the 5th power is 3125 over 5. 625 times pi minus 0, so 625 pi units cubed. This is one arch, and then this is from 0, and this is pi. So integral from 0 to pi of sine x squared dx times pi. Remember, this is equal to this, so that's 1/2 minus 1/2 cosine 2x 0 to pi times pi dx. X over 2 minus, what is that? Minus sine 2x all over 2 from 0 to pi times pi. And this is the 1/2 in front. So it's x over 2 minus sine 2 x over 4 from 0 to pi times pi. So pi times that pi over 2 minus sine of 2 pi is 0. 0 over 4 minus 0 over 2 minus sine of 0, 0 minus 0. Ooh, this is pretty. See you later, see you later, see you later. So that's just pi times pi over 2, which is pi squared over 2. You write that pi caret 2 divided by 2. Kind of a weird answer. Here's a washer. Remember, you do the top function minus the bottom function. So integral from 0 to 1 from pi. Top function is this, so it's square root of x squared minus x squared dx. Pretty, right? X minus x to the 4th from 0 to 1 times pi dx. So that's x squared over 2 minus x to the 5th over 5 from 0 to 1 times pi. that's 1/2 minus 1/5 minus 0. 1/2 minus 1/5 is 3/10 times pi. So 3 pi over 10. The shaded region below is blah. It revolve about the x-axis, so it creates a washer. So your top function is x, bottom function is 1 over x. And then you're going to, you find this intersection point. I bet that's 1. When is x equal to 1 over x? X squared equals 1. X equals plus or minus 1. So that's 1 to 2. So integral from 1 to 2 times pi. Top function is x squared minus 1 over x squared dx. So x cubed over 3 minus 1 over x squared. So that's x to the negative 1 over negative 1 from 1 to 2 times pi. So x cubed over 3 minus plus 1 over x 1 to 2 times pi. 8 over 3 minus 1/2 plus 1/2 minus 1/3 plus 1 over 1. You get 7/3 minus 1/2 times 2. 14 over 6 minus 3 over 6, and you get 11 over 6 times pi. You get 11 pi over 6. Kind of a weird answer. But do you notice how like these really cleaned up nicely? Last problem. Find the shaded graph. This is y equals 1 from 4 to 8. So integral, coordinate, this is not 4. So you say 1 equals the square root of x minus 4. Square root of 1 equals x minus 4. X equals 5. So from 5, so that is 1 comma 5, no, 5 comma 1. And you got x minus 4 square rooted squared minus 1 squared. Do you notice how clean that's going to be? X minus 4 minus 1 squared. 5 to 8 pi. That's negative 5x minus 5. So x squared over 2 minus 5x from 5 to 8 times pi. 64 over 2 is 32 minus 40 minus 25 over 2 minus 25. Negative 8. Negative 8 minus plus 25 minus 25 divided by 2. Get 4.5. And there you go. These are just review problems that we probably won't ever do. So do me a favor, please. Upload notes right now. And your homework is one 105, 106, and 107. So I hope that helps you all with your notes.